everybody. Well, I've been awake about 29 hours so far. I'm going to bed soon. But before I do, I feel like opening up a little bit about my project. You might recall my Akkadian noun analyzer, which used regular expressions and string pattern matching to find, well, to basically find morphological properties such as case, gender, etc. I decided to go one step further and implement what is practically a context-free grammar in Python standard library. Excuse me, but let's get down to business, and let's start with the lexicon. So the lexicon basically only has POS tags. So there's a determiner. So the thing is that after all phrase structure rules are applied, then it begins to pick random sentences. As you can see, there's a good number of them right here. Yeah, a pornographic obituary writer reschedules our language shrine maiden beyond our unavailable middle manager because my Scandinavian editor traumatizes our lukewarm teacher beside your stupid mink, for example. And it's meant to be partly humorous, but it's also meant to be a real learning opportunity. Mainly because I've wanted to. So basically, let's get down to business. So, and then let's talk about the grammars. Now, these are just regular, your average context-free grammars. There isn't much to say. There's some rules wherein I stray from the traditional kind of way that English is laid out. Like here, for example, I got a noun phrase and it opens up into 5 nodes. Yeah. Uh I can I'll probably like work on the grammars again tomorrow, but and shorten this to like a DP to like get a determiner phrase and then a noun phrase, I guess. And then but the thing is and I think that the conjunction right here, I think that the conjunction should not belong in NP. But so it goes. It still generates these fun little funny sentences. In any case. So, but let's get to actually the CFG engine itself, because this is really the main thing. So this uses pretty much Python standard library. So um random is one of the, so basically it starts off with class CFG, and then in it self rules. So self rules, it's one of these grammars. It corresponds to one of these grammars. As you can see in main, the argument passed in is just a random one of these grammars. So POS tags is just from grammar. Current symbols is the flattening of the expansion of just this string S, because all of them start with S. So let's talk about the recursive logic here. So expand. So basically, first of all, it verifies if all of the if all the phrase structure rules are applied. And how does it know this? It knows this when all of the entries within the list pretty much are all POS tags. Therefore, there's nothing left to really expand. Those are the penultimate non-terminals. Um, those are the penultimate non-terminals. But let's get to it. So, because they're arranged, because the derivation rules and the strings are kind of arranged in nested lists. Yeah, I mean, yeah, pretty much what it basically does is first of all, it starts with no symbol, an empty thing. So then it checks for symbol in symbols, that is to say, in S or in whatever level. It checks if it's a list. If it's a list, then it runs this all over again. All right. And so if there's a list and rules. Then it expands the list again, and it runs all of this over the right hand side of whichever one. And you have to remember, all of them are array. All of them are lists, so it kind of expands them until they're kind of done. So then, if nothing else, then it just appends the symbols regularly. But yeah, list. So if it's a list, therefore it's a series of non-terminals in an array. Um, because of the fact that every symbol is it's one symbol, because it's context free. So the left hand side can't be an array. It has to be a string. It has to be a symbol. So it just expands the symbol pretty all right. But then if it's a then well we run the same exact function over the right hand side, and then do the same over that, do the same over that, etc., 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 until I guess all of them. And yeah, as well, of course, return new symbols, because it has something to. It requires. So the base case is all of them are validated, and then it begins to kind of do that, and then flatten. Uh, Now this is actually because I'm kind of new to Python. I didn't actually know about the whole extend versus append difference. So basically, if it's an array, then it adds all of the items one by one, and recursively so. So if it's an array, then it looks inside the array, and then it looks inside the array, etc., etc., until, and then it adds each element of the array one by one. But if it's just a symbol, then it just appends it normally. And then, of course, definition validate. Basically the same exact logic as expand, except it's just checking. It's not really doing anything of that nature. And finally, pick words, yeah, which is kind of, so basically, when it gets to a level where every single non-terminal symbol is lexical, it's a lexical, it's like a part of speech tag, then it picks a random one out of these, out of all of these. These are funny. These are pretty funny. But okay. I think. All right. And then, degree. This is one of the most cavemanish solutions to a problem that I've ever seen. It's so unbelievably cavemanish, to the point where agreement rules are, I, literally, just look at this. If the symbol is ah, and the word that comes after, and there is a word that comes after it, which there always is, but, it's good to write it down. So this is kind of redundant, but, Python is very explicit, you know. If the word that comes after starts with a vowel, then it changes it to an. And now, well, what did I learn from this? Well, first of all, I learned how to implement a context-free grammar. There were some parts wherein I architected it beforehand in my mind, but I didn't know the exact Python lingo for it. For example, this thing here. I knew what I wanted to do for it, but I didn't know that this was particularly the way, so I had to check that out elsewhere. I had to check that out elsewhere. I had to sail a little bit. But this also was a very good learning opportunity. You might ask why this is a good learning opportunity. Well, it's because I learned why pretty much all of the linguistics people that actually still do actual, like, formal linguistics, people who implement these kinds of formal, very well-defined grammars with phrase structure, etc., I see why they use Lisp or Prolog, because doing this in Python is a nightmare. Like seriously. And naturally, of course, it's Python isn't fully meant for this, which kind of convinced me that to actually start studying Racket in particular, which is a dialective scheme, and it's particularly built for designing formal languages, programming languages in specific, but that's neither here nor there because I think fundamentally the entire generative tradition pretty much kind of says that even if you invite probability and even if you invite chance into language, which fundamentally language is somewhat down to chance, you're still going to need formal grammars. You're still going to need to define a probability space over a formal grammar. But so I guess in the most fundamental sense, there isn't much of a difference between programming languages and the but that's neither here nor there. Um, but actually, let's show you a bit of the funny sentences. Let me show you. For example, we got the uninvited cat traumatizes a moist barista towards a pornographic lifestyle coach, and a pornographic ontologist abducts the moist dog for her offensive mink. Very cool. Yeah, I literally just ran this for like 500 times. Uh, these are funny. These are kind of supposed to be funny, but I think they're a bit too risque. I might actually make this private and then make another version that's actually kind of that's substantially nicer. But that's only really if I that's only really if or when I need to show this project to other people, which I will have to eventually. I know I'll have to. And therefore, so I guess this is my fun version. This is my having fun version. Okay, thanks. Thanks for watching.